Dr. Eris Thorne, a senior defense analyst, declared this morning that the long-held assumption that Iran's asymmetric doctrine in the Strait of Hormuz was an unanswerable challenge has been decisively shattered. That declaration comes as we report on a dramatic confrontation that unfolded just hours ago. At 2:47 a.m. Eastern Time, in the Strait of Hormuz, the radar of an Arleigh Burke-class destroyer patrolling the blockade suddenly sounded a red alert. Dozens of high-speed lights were hurtling toward them from multiple directions. Iran had just launched a swarm attack. In just 90 seconds, dozens of IRGC fast attack boats would be within rocket range of a United States warship. What happened in the next 2 hours would determine whether the Strait of Hormuz remained open or became the most consequential naval engagement of the 21st century. Welcome to our special coverage. This report is a deep dive into the military, geopolitical, and economic stories reshaping our world. And what you are about to hear is the minute-by-minute tactical breakdown of how a single U.S. destroyer faced down Iran's asymmetric swarm doctrine in the Strait of Hormuz. Dozens of IRGC fast attack boats, smart mines, one-way attack drones, electronic warfare, and coastal missile launchers, all converging simultaneously on one ship. What happened in those 2 hours will be studied in naval academies for the next generation. The geopolitical architecture had already collapsed. Washington's maximum pressure campaign had backed Tehran into a corner from which it saw no exit through negotiation. The Islamic Revolutionary Guard Corps had activated Operation Hormuz Gatekeeper. The mission was not symbolic, it was operational, established absolute control over the world's most critical maritime choke point. Iran was no longer merely issuing threats. They were demanding protection fees and declaring they would turn the strait into a graveyard for any Western oil tanker daring to challenge them. What followed is a case study in what happens when asymmetric doctrine meets integrated naval warfare. At 2:30 a.m. at the eye of the storm was an Arleigh Burke-class Flight 3 destroyer, a $2 billion engineering masterpiece from Lockheed Martin. But it was not alone. Above the clouds, Boeing's all-seeing eye, the P-8A Poseidon, the U.S. Navy's premier C-4 ISR command and control hub, was continuously transmitting mapping data to the fleet. The P-8A Poseidon detected mobile missile launchers and a fleet of high-speed boats leaving their hiding place immediately to establish a reconnaissance perimeter. An MH-60R Seahawk helicopter took off, deploying sonar buoys and detection equipment to scan for Maham acoustic mines beneath the murky water. This initial deployment highlights a critical shift in naval engagement strategy. Historically, individual assets operated with more autonomy. The immediate, seamless integration of air, surface, and subsurface reconnaissance, coordinated by a single airborne hub, demonstrates a level of networked warfare previously theorized but rarely executed under live fire, challenging traditional notions of independent platform survivability. At 3:01 a.m. over the Strait of Hormuz, the digital fog began to thicken. The P-8A Poseidon, the U.S. Navy's airborne command center, shifted from passive surveillance to direct coordination. The crew deployed a series of ASQ-53G radio buoys, originally designed for anti-submarine warfare. These sensors were recalibrated to detect the acoustic signatures of IRGC speedboat engines amid the turbulent waves. A real-time digital map with extreme precision pinpointing the Iranian fleet location was established. The data was immediately encrypted and transmitted to the fleet via the Link 16 system. Every platform in the battle group was now sharing a single, integrated tactical picture. At 3:08 a.m., thanks to this data, the MH-60R Seahawk, flying on the edge of the combat zone, carried out the first physical strike from a distance of 8 kilometers, beyond the range of Iran's 12.7mm machine guns. The crew locked onto the command vessels via the MTS electro-optical system. 2 AGM-1114 Hellfire missiles were fired, tearing through the night with long trails of fire. The laser-guided missiles precisely destroyed the lead boats in a blaze of fire and shrapnel. The IRGC formation faltered as its command center sustained damage, causing communication between the smaller boats to begin breaking down. What had been a coordinated swarm was becoming a collection of individual vessels without central direction. At 3:14 a.m., the IRGC immediately launched its asymmetric counterattack. An electronic wall was erected as hundreds of Ababil decoy drones were launched from coastal caves toward the Arleigh Burke-class destroyer's Spy-6 radar. The initial 50 targets suddenly multiplied into 500 flickering blips. The Aegis combat system struggled to classify the threat amid intense metal clutter and high-intensity electronic noise. At the same time, Fudger 5 rocket launchers on the coastal cliffs unleashed a barrage of rockets. Rather than targeting the ship directly, they fired hundreds of rockets into the water in a grid pattern around the U.S. destroyer. A series of massive 15-meter-high water columns created a continuous curtain of saltwater spray and steam that shrouded the ship. This was a tactical smokescreen designed to blind infrared sensors and laser rangefinders, forcing the U.S. crew to operate inside a layered environment of electronic and physical interference, exactly as Iran's asymmetric doctrine intended. The battle reached its first critical inflection point as Iranian coastal units began to lock on to the U.S. fleet. The Arleigh Burke-class destroyer immediately initiated counter-air defense operations utilizing coordinates from the P-8A. The Mark 41 vertical launch system fired a salvo of precision-guided missiles, destroying the threatening launchers the moment they locked onto the radar. Simultaneously, the SLQ-32 electronic warfare system emitted an extremely powerful concentrated energy beam, overwhelming the receivers of the IRGC's coastal radars. This combined firepower and electronic warfare strike created a temporary blind spot along the Iranian coastline, a narrow window of opportunity the U.S. Navy had been holding in reserve for precisely this moment. At 3:26 a.m., as the main air bases were overwhelmed by long-range interception missions, a pair of A-10C Thunderbolt II aircraft from the Al Dhafra Air Base were urgently deployed. These Warthogs had been specifically configured for the swarm-busting scenario. Unlike supersonic fighters, the A-10 can maintain a steady, slow flight at 300 knots. Combined with the Sniper Advanced Targeting System and night vision, it becomes a precision hunting platform with the patience and endurance to track individual, fast-moving surface contacts across a vast, dark expanse of open water. At 3:33 a.m., exploiting a blind spot in IRGC radar coverage, the pair of Warthogs plunged down from altitude to avoid detection by early warning systems. They wove through the 150-meter-high, sheer limestone cliffs along the Iranian coastline, using the rugged terrain to stay below radar detection range. They suddenly appeared at an altitude of just 30 meters, their wings nearly slicing through the foaming white waves. IRGC soldiers fell into a state of utter panic at the screech of jet engines right overhead. Amid the roar of the engines, the A-10 pilot faced shoulder-fired anti-aircraft fire and one-way attack drones frantically charging toward the air intake. The A-10's low-altitude, terrain-following ingress, typically associated with ground attack, represents an unconventional and high-risk maneuver for maritime interdiction. This decision to deploy a slow, heavily armored aircraft in a high-threat naval environment, rather than faster, stealthier jets, underscores a calculated tactical gamble, prioritizing loiter time and precision over speed, a departure from standard air-sea engagement protocols. At 3:38 a.m., the sky blazed with a network of tracer rounds and flares. American pilots strained to execute 7 forced turns just above the water's surface, causing blood to rush to their feet and their vision to narrow, all to evade the rain of drones and missiles. They continuously dropped chains of magnesium heat-seeking decoys burning at 2,000 degrees Fahrenheit, creating blinding flashes that reflected off the pitch-black sea. Amid the chaos, the A-10 formation stabilized, and the pilots locked onto targets via their HUD screens. The G8 Avenger cannon officially let loose. The distinctive brrrt roar echoed, drowning out the sound of the ocean waves. Every second, 65 30mm depleted uranium rounds tore through every obstacle, turning the fleet of speedboats into flaming debris and long oil slicks on the water's surface. At 3:46 a.m., as the battle on the water raged fiercely, a new invisible threat began to emerge from the depths below. The Seahawk immediately switched its multi-mode radar to high-resolution, short-range scanning to search for small objects near the water's surface. The sensors began picking up faint metallic signals just inches above the churning water. These were not waves, they were the rhythmic signatures of Iran's Mahamlas smart mines. sophisticated explosive devices anchored to the seabed, designed to detonate via acoustic or magnetic triggers. The pilot's voice echoed over the secure communication network at emergency priority. The Vampire isn't the only threat. We have an underwater minefield at coordinates 7 Alpha. Hard turn immediately. At 3:51 a.m., inside the Arleigh Burke-class destroyer's Combat Information Center, the atmosphere shifted from an offensive stance to survival mode. The captain ordered an emergency stop and executed a sharp, hard-to-starboard turn. The 9,000-ton destroyer heeled over, its hull groaning under the strain as it narrowly avoided a cluster of mines that could have ripped the ship in two. The ASQ-89 system detected the Maham Strait, which was heavily mined, and living torpedoes, semi-submersible one-way attack boats, closing in. The Arleigh Burke-class destroyer found itself in a pincer movement. It could either remain stationary and take the hit to sweep the mines, or move to evade the suicide boats and risk hitting a mine. At 3:57 a.m., this is the doctrinal trap Iran designed its asymmetric strategy around. The convergence of multiple simultaneous threat systems, each individually manageable, combined into a situation where every response to one threat creates exposure to another. The second wave of the swarm, faster and more aggressive than the first, began to accelerate. These boats are designed to ram ships at the waterline, targeting the thin steel of the hull to cause catastrophic flooding. The U.S. crew was now caught between the mine-laden threat and the one-way attack boats, with only a few seconds to decide between being slowly sunk or blown up instantly. At 4:04 a.m., with the fleet pinned down, the captain of the Arleigh Burke-class destroyer authorized the nuclear option of non-physical warfare, activating the full power of the shipborne electronic warfare system. This was not mere jamming. It was a high-intensity electromagnetic wave attack. The destroyer's electronic warfare arrays focused an extremely powerful radio frequency energy beam sweeping across the strait. The effect was immediate. The remaining Ababil decoy drones, having lost their GPS signals and command links, began falling from the sky like dead birds. The IRGC's one-way attack swarm lost its cohesion. Without central coordination, the speedboats began colliding with one another in the darkness. Their pilots blinded as their navigation screens displayed nothing but white static. At 4:11 a.m., as the electronic fog cleared the path, the ship's defensive perimeter contracted in preparation for the final engagement. Raytheon's Phalanx CIWS close-in defense system, affectionately nicknamed Hot-Tempered R2D2 by the crew, began its automatic search and destroy cycle. Its internal band radar locked onto any object moving faster than 20 knots within a 1.5-meter radius. The M61A 120mm Gatling cannon began to rotate its barrel, spitting out a continuous stream of tungsten armor-piercing rounds at a rate of 4,500 rounds per minute. The night sky was illuminated by continuous flashes from the gun muzzle as the Phalanx system shredded the living torpedoes less than 500 meters from the ship's hull. At 4:17 a.m., at the same time, the 5-inch Mark 45 Mod 5 version 4 naval gun at the ship's bow, manufactured by BAE Systems, began firing at a rapid rate. It used airburst rounds with multifunctional fuses. These rounds were programmed to detonate precisely at a height of 3 meters above the water surface, creating a deadly cone of fire containing thousands of shrapnel fragments. This rain of molten metal swept away the last remaining IRGC speedboats that had managed to evade the Phalanx barrage. The strait, once a chaotic swarm of Iranian aggression, was now a debris field. The U.S. Navy did not merely survive the blockade. It engaged Iran's asymmetric doctrine across every layer it presented: kinetic, electronic, aerial, surface, subsurface, and systematically defeated each one. At 4:28 a.m., the nature of the battle officially shifted from desperate defense to deliberate retaliation. The Arleigh Burke-class destroyer was no longer prey. It had become the hunter. High above, the Boeing P-8A Poseidon used its A-10 radar to see through the gunfire and water spray, pinpointing the exact source of the aggression. The hidden missile silos and submarine bunkers of the IRGC carved deep into the limestone cliffs on Keshem Island. The coordinates were transmitted in real time to the A-10 Warthogs. The Warthogs returned for a final strike, this time carrying Raytheon's GBU-12 Paveway 2 laser-guided bombs, guided precisely by the Poseidon's laser designation system. The bombs struck the cave entrance with absolute precision, triggering secondary explosions from fuel and ammunition depots, collapsing the IRGC's secret bunkers and burying the remaining reserve forces under thousands of tons of rock and debris. At 4:41 a.m., the blockade was intact. The Arleigh Burke-class destroyer advanced deep into the main shipping lane, asserting absolute control, leaving behind the ruins of an operation that had gone up in smoke. Tehran's Hormuz gatekeeper operation was systematically dismantled in less than 2 hours. The strategic advantage Iran had hoped to secure, the power to hold the global oil supply hostage, had evaporated into the morning air. And here is the strategic conclusion this engagement makes unavoidable. Iran's asymmetric doctrine in the Strait was always built on a specific assumption, that the convergence of simultaneous threat systems, swarms, mines, electronic warfare, coastal missiles, would create a decision environment too complex and too costly for the United States Navy to engage directly. The doctrine was designed for a Navy that would hesitate. What the IRGC encountered instead was a fully integrated battle network, where every platform shared a common tactical picture, and every threat was engaged at the layer most efficient for its defeat. Iran did not merely lose a naval engagement, it lost the operational validation of its primary deterrence architecture. A single tactical decision by the IRGC command, choosing open kinetic aggression over the patient asymmetric pressure of covert mine-laying and attrition, gave the U.S. Navy a defined target set and clear engagement authority. They walked into the one scenario where American technological integration produces its maximum operational advantage. Iran's greatest strategic asset, the credible threat to close the Strait of Hormuz, was spent in a single morning. This outcome fundamentally redefines the viability of asymmetric naval warfare against a technologically superior, integrated force. The rapid and decisive defeat of a multi-layered threat designed to overwhelm suggests that the perceived cost-effectiveness of such doctrines may be severely overestimated when facing a fully networked adversary, potentially forcing a re-evaluation of naval deterrence strategies globally. And what it bought was a debris field, and a lesson that will be studied in naval academies for the next generation. We will have continuous coverage of the Hormuz naval engagement, Iran's asymmetric doctrine collapse, and what this means for the future of naval warfare in contested waters.